Okay, hello, this is HJunkes from the Fritz Haber Institute. This is now the last talk in this first day, Epics for Beginners. And I hope there are some attendees left because it's very late in Germany, in Berlin time. I will present the installation of Epics Space on a Raspberry Pi, and we will also put some analog digital converters and digital converters hardware on the Raspberry Pi. My name is HJunkes from Fritz Haber Institute, and I will do it together with my colleague Patrick Oppermann. He's at the Albert Einstein Institute in Hanover, and he will help me to install the software and do all the stuff. Hello, Patrick. Hope you are okay and it's not too late for you.
Hello, Heinz. Everything's fine, and I'm happy to look forward that we can show the audience some Epics and some working Epics parts. So let's start.
Okay, before we install it on the Raspberry Pi, I will just show you how to install the Epics in general, the Epics Space, and I will do it on my working horse. It's a MacBook, and I will first install the Epics on the MacBook to show you how it's working and how it works. And after that, we will try to put everything on the Raspberry Pi as a demo. And first of all, I will create a directory on my MacBook to install the software Epics Space test. And I will install the software out of the Epics repository. And I always forgot where it is and where the repository is. And where can I find the repository, Patrick?
We have everything pretty easy to find on our epics-controls.org website. I will open it for you. And here you can find the support button. And under the support button, you find everything for starters in the Epics world. I really recommend the step-by-step guide to start with. And let's go there. And as you see in the beginning, it's installation on Linux, Unix, and for example, also your Mac that you want to use. So let's start from the very beginning. Your system should be prepared for it, and then we can start with the installation.
Okay, I think I already have it on my MacBook because I'm using the homebrew stuff, and I have installed all the necessary stuff like compilers and makefile and those already there, and therefore it should work. With the repository, there's a link also on this page. I copied it. It might be this one, and very important is the ---- recursive. Otherwise, the PV access stuff will not be downloaded. And it's just to clone the repository. And important is the ---- recursive. And if you have some further questions after this demonstration, we have also a website with informations. It's sponsored or funded by the Max Planck Society. We have an Epics at MPG initiative at the Max Planck. And on this site, you will also find other informations to run small experiments. And also we will help you if you have further questions. Even if you are not a member of the Max Planck Society, it's just a collaboration. And I see the git clone is done. Then there is a directory called Epics Space. I will move to the Epics Space. And now it's pretty easy. You just have to type in make. That's all. And now the Epics Space get built. And we will move over to the setup of the Raspberry Pi, of the setup of the hardware. This will be our next step. Patrick, we will now move to the next step, or?
Let me just give you one short thing about our webpage, epics.mbg.de. We have these in two languages, so if if you're not familiar with the English, you can just switch to German language and then just work on, just look at it. So we have everything there, and you find also our contacts and options of video communication and stuff like that. So just contact us if you need help.
Okay, so now I will try to build up the Raspberry Pi with the analog board add-on boards, and therefore now I have to move the camera to the hardware stuff. And you will see in the background it's very crowded, but this is all the devices we run with the Epics. For example, a Cora Z7. We have also run an Artems on it. There are some other, there's an BeagleBone board we run with the Epics, and even PLCs is a Galil controller run with Epics. And even in the background you have these MTCA 4 systems, very powerful systems. Even on all these devices you can run the Epics stuff on it. But today we will start with a Raspberry Pi, and you see I have 3 boxes, and these 3 boxes is the first box, and I will open it with you together. It's a surprise box or whatever. There's a cable to connect the monitor on it. There is a Raspberry Pi 4 computer in it. Oh, it's this one. I see it's not that sharp. And there's the power supply for it, case for the Raspberry Pi, and even a predefined SD card to run the Raspberry Pi. I bought this complete package to show you that there is a beginner package like this. This is the Raspberry part, and then we have some boxes with the hardware modules on it. There is one module is the analog digital converter, and you have also some screws and bolts and connectors. And this is the other box. And I have to build now the stuff. That means I have to put on the Raspberry Pi the hardware boards, for example this board, and I have to fix it on the Raspberry Pi. And I will start to do this assembling. And in the meantime, Patrick can show you why we do this stuff. And what I do now is to connect the boards to the Raspberry Pi, and I have to do some mechanical stuff there. Okay, Patrick?
Yeah, so we decided to go for some analog digital converter as well as digital to analog converters. The company we are getting this stuff from is MCC DAC, MCC Measurements, and there we decided to go for a really easy approach. So we want to have a data acquisition, and we just want to go do it with our Raspberry Pi. So if you go there on the website from the company, you see there are 4 modules that you can get for as Raspberry Pi heads, so you can just stack them onto each other. You can even stack them multiple boards onto each other. And we decided to go for the MCC 118. That's an analog to a digital converter. It's 8 analog channels. We have a sampling rate of 100 kilosamples per second with a resolution of 12 bits. And to also get some signals out of our system, we also want to go from the digital to the analog world. Therefore, we decided to go for the MCC 152. It's an analog digital to analog converter. We have 2 channels going into the analog world. We have a couple of digital IOs that you can use later on, and we're also working with a resolution of 12 bits here on this system. And the nice thing is really that you just have your Raspberry Pi, as Heinz said it now, and you just stack these 2 additional boards onto each other and then onto the Raspberry Pi, and we can then work with it. If you are really interested in it and want to see what we want to do, we also have everything that we show now on our Epics website. If you go to the Epics website, I will turn it into English. And then you see that, for example, we have under hardware our MCC duck heads. And here you can find, again, a link to the webpage of the manufacturer, where you can find some additional help, like libraries and stuff like that, but also complete tutorial how to install everything onto this machine, that it just works out of the box. And I don't know, Heinz looks like he's almost ready.
No, it's like Lego, but I need the second board. The first board is already connected. You can see this piggyback, and now I have to add the second one. And oh, the compilation is ready. Oh, already done. Then I will try the next step, make tests. No rule to make test. Make, oh, minus help. Make run tests, I think it's called. Make run tests. Make run tests. No. Oh, okay, I have to look for how to run the tests. Okay, I will try it like in the next step. First I will add the second part on it, and then I will come back. So, ta-ta, I got it. Now you can see the Raspberry Pi with the two modules, with the help of the right screwdriver and all the stuff. I could manage to put all the things together. And now I also remember my fault was just make test instead of make tests. That was all. And you can see make tests runs through, and now this part is ready. And for the Raspberry Pi, I need the power supply for the Patrick, can you have a look? There was another command, make run tests, or like this. Not that I do the next mistake.
Did you do make test?
Yeah, make tests. And there is a script called run
test.
What?
Not tests. Test.
Yeah, I tried make test.
Okay.
Okay, that's finished. And now I have to run the tests. But first, yeah, no, I know. First of all, I should now install the path to the binaries of the epic space in my bash RC, that for the next time, if we try to run the make base example, and therefore here you can find now the binaries which are created, and you see there are some channel access commands like ca put, ca get, ca monitor, and even make wrappers like make base app we need in the next step to make an example. And therefore I will add the path in this place into my bash RC file, that it will get in the path where the binaries get searched, and therefore I have to add the path in the bash RC, and therefore I will add dot bash cd vi dot. Or the Macintosh, it's profile, and you can see here a lot of these settings already in my bash RC file from my further examples. And here you can see there is the epic space defined, and now I will create a new one. Epic space, and this is now for our tests. It's a user space, Escape. So sorry for that.
On the Epics Controls website, in the tutorial, you can find the easy way, and you can just copy and paste it in there into your .pro files or into your .bashrc files. Just copy and paste the 3 lines that you can see here on the website into your file, and then just have to restart your terminal to get this up and working.
Yeah, I've created a new bash, and now you can see that it will find, for example, the right thing I just created here if I look for the get command. So, and if I go to Epics space, I think it's now defined, and there is a directory test, and sorry for that. And there, the next step would be now to create a base application. And for example, we can here the Apex is called my example, cd my example, and make base app pl my example minus, how do you call it, Patrick? Make base app minus.
We have that also on our web page. So let me find for you. It's test Epics base, and here you can find what to do. Here I have an example, make base app. That was the script that Heinz wants to use now. It's -t/example/my example.
So that's the type.
Yes.
And to have a bootable, I have also to create a such called IOC. That's -i, and the name should be the same as the example. And now we have created example stuff. And even with the Epic space, you just have to type in make. And then you have in IOC boot, IOC my example, a startup file called st.command. And in this st command, the examples get started, and I have to make it executable. chmod -x st command, and now I can start the st command, hopefully, and you can see this is an example, Epics IOC example. These are the PVs which are and these PVs are available on these example stuff, and you can have a look for the record in this one, for example. But this is now, that is, you will find all the stuff in the record manual and all things. But this is the how the Epics is working, and you can see here an example, and you can see the value. For example, it's now 44, and now it's 47, and this IOC runs now on my Macintosh. And sorry for that. And if you want to run to see what happens with this variable, you can run in another bash or on another computer, for example, chmonitor, and this was, how was it called? Angel. And now you can see that it changed the value, 82, 83, 84, 86, 87. This is the date where it has changed, and this is the severity. This is low, but now there is the Epic space running on this Macintosh, the example, and you can access it from any computer in the network, and you can read the values. You can also put values on it. For example, there is a computational C is A.B. You can also change B or whatever. And this is now the Epic space and the example running now on my Mac. And the next step will be, we will put the same stuff on the Raspberry Pi, and therefore we have now the next step to run the Raspberry Pi on our network. And I prepared the Raspberry Pi, and okay, it's dark, it's getting darker. Okay, it's the other direction, the Raspberry Pi with a power supply, and we have to put in the, this list, oh no, it doesn't, okay. And I have now to put in the prepared CD card into the Raspberry Pi. I saw, this one. It's the little one in the, I can't get it out. Okay, these are the problems I like. Okay, I now put the card into the Raspberry Pi, the right direction. Nope. It does not fit. Okay, now I have the problem that it does not fit.
Perhaps I can tell something in the meantime.
Okay, now it's good. Yeah.
If you want to check your Epic space that you built, the example in the Epics-controls website would also be to just start a so-called soft IRC, and therefore you just type in the command soft IRC, and then you see that your system is changing to a different setup, and it says just Epics. And there you can use then the Epics commands that Heinz already told you to exit it. You just need the Control C to hit it, and then it's going on. But what Heinz already did is our actually first step, what we need for our MCC module to be installed, and therefore we have to make an example anyway. So that's not the same that we did. So we will use that IRC that Heinz built later on Raspberry Pi.
Okay, now we have to connect the Raspberry Pi onto the network. That's our next step. Okay, now Patrick, now I remembered how to run the tests, and you have to type in make tab files. And then the test files gets generated in the Epic space, and that was what I was missing 10 minutes ago. And when you have the tab files, then you can make run test. I think it takes a little bit with the generation of the tab files. And in the meantime, with the Raspberry Pi, now I have built up everything. And to get the Raspberry Pi into the network, you first have, in our network, we have to determine the MAC address. And unfortunately, there is no MAC address on the board, printed on the board. And therefore, we have to get the MAC address of the Raspberry Pi to connect the Raspberry Pi to the network. And therefore, there's a stupid work, but you have to connect the Raspberry Pi to a monitor, to a screen, to a HDMI screen, and therefore I have set up now the Raspberry Pi with internet, with a keyboard and a mouse. That's what you need to connect to, and even the HDMI cable. And there I'm using now Raspberry version 4, and there are two HDMI connectors on it, and you have to use the one which is near to the power supply. And then when I switched on the Raspberry Pi, this is the monitor. You see that's my chaotic screen. It starts up with a graphical interface, and then it prints out the MAC address of the board, and you have then to type in the MAC address into the Raspberry, into a DHCP server or whatever. And you have to do it once, And then you don't have to forget that you have to enable the SSH daemon on the Raspberry Pi, and this can be done with the mouse and with the button. And here you see the graphical interface of the Raspberry Pi we are using here with this box, with this kit. And then you have to define, you look for the MAC address, and then you can run ifconfig -a, and then you will get you can't see it now, but it's on the screen here, and then you can define the MAC, you have the MAC address and you can put it in the DHCP server. That was just to get the Raspberry Pi connected to the network, and after that you can connect to the Raspberry Pi. For example, I will do it like this, and SSH Pi at, this is the address it's using, it got from the DHCP. Oh, yes. And the Pi password is Raspberry, I think. And now we are on the Raspberry Pi, and now we are doing the same steps as with the Mac before. That means we have to first of all, we have to install the compilers, and I think that's apt-get install g++. No? I have to sudo. Yeah. Oh, it's already installed. Then we can run the git clone, or?
Yeah, it's directly working.
Oh, I'm surprised now. Okay, mkdir epics test and cd epics test, and then it was, oh, let me have a look on the other side in the history. Git. Okay, it was here git. Oh, this was the wrong.
It was, you can find it on the web page from the Epics controls in the guide. So back to the Epics controls website.
Git is already installed? No.
It's also
the Git, it's already, it's perfect. Git clone --recursive, then HTTPS, gell?
Yes.
/github/epicspace. Like this?
HTTPS github.com/epics-space/epics.
github.com/epics-space/epicspace.git, or? Could not resolve the, that's the problem with the DNS. I have to, NS, look up. github.com. This. That's the stupid new modern. Okay, I have to fix this first. Sorry, Patrick, it was my fault. I forgot a slash, that's all. Okay, it was a little bit, out of, and now it runs Epics clone. Git clone. Oh, the Raspberry Pi is faster than my MacBook, I think. It's a new experience, but it's a Raspberry Pi 4, I think, and it's not that bad. Oh. Okay, now, now we have this cd epics space, and now make, or Patrick, that's all.
Yeah, just make it. You can go with -j.
Okay, there are some problems with the language setting because I'm connected via the Apple SSH, and there is some missettings with the language. Now we can move over to the next one. There I have make tab files. I can close this window. Okay, make tab files, and after that you can type in make run tests. And now it's running the tests on the Epic space. And when you install the Epic space via git clone, then you should always run make run tests, also make tab files to generate the test files, and then make run tests to check that everything is working and on your system. And after that, you can start with my examples. And you're seeing on the left side now there's the tests running on Epic Space. On the right side, now we are compiling the Epic Space on the Raspberry Pi.
I think I want to add something at first. I also use the GitHub for that stuff. But if you don't want to use GitHub, you can also just download a file for the Epic Space and then make this file. But you can also, and also I want to add that sometimes we create a new user on our Raspberry Pis, that we have a user called Epics just for convenience, that it's not just a Pi user. So it's just some hints when you work with multiple systems. Sometimes it's useful to have some little tweaks that the systems are as close as possible to each other, that you can switch in between.
Okay, now we are ready with the compilation, even with the tests on the Macintosh MacBook. And here you can see that on the MacBook it ends up with all tests successfully, and there is a test summary report. There are 88 tests and 0 failed. Everything is okay. And as expected, it runs because we already run the make base up. And on the Raspberry Pi, it's also ready, and everything is compiled, and you see everything is done. And usually you should now run there also the make tab files and make run tests, but now we have to be a little bit faster to get to the end. I don't want to run these tests. The next, we have to add the binary, we have to add the path, to extend the path to the new installed binaries, and therefore we have to add in bashrc on the Raspberry Pi, at the end of the bashrc file, we have to add the Epic Space export. Sorry for that. $home. Home. Epic test Epic Space, and we have to add the path. Okay, we have to set the Epic path Epic Space bin. Oh, I don't know the Epic's host architecture. Let's have a look. Epic test cd Epic Space cd bin, and you see the host architecture is Linux minus ARM, and in this directory we have the files like pvget, pvmonitor, pvput, and crget and crput and all these things. So we have to add bashrc export Epic's host architecture is gleich Linux ARM. and source.bashrc instead of starting a new terminal, we can source the bashrc file, and now we should find get and see, okay, it's on the right place. And the next is to run the Epics base app, make base app, and this was the same as on the Mac. I type example, and I choose the example, and these are messages, wrong definitions for LC all or whatever. It's just the output from the Perl, and you can see there are now the files created, and then we have to create the IOC -i. Now we have the IOC, it's the same name, and now we can run make, and the same stuff as with the MacBook. It will create now the example file. You can just ignore the Perl messages. There's now IOC example, and I will do the same. User may execute st command, and now I can run st command. And the files, they called p, calc, we had the circle example, for example, here circle x, or yeah, we have the circle angel, for example. And from these files now can be seen by the MacBook. Oh, I have to find there. So, and we can now run on the MacBook on this get circle, and you will see we will get the value of the PV on the IOC running on the Raspberry Pi. And we can see these PV on any computer which is connected to the same network. And we can also do a CR monitor. And you can see the angel is changing every second. And this is how the channel access is working and how you can deal with distributed IOCs. Okay, Patrick, I think now it's your turn, or I have done everything. I showed to you how to install the Epics on a Raspberry Pi with this MCC stuff. And hopefully you have also in the meantime set up a Raspberry Pi and can do the same stuff.
Yeah, so I have the very same Raspberry Pi than you, with added the heads to it. I put it into my network here in Hanover, and I'm also ready to use it. So I actually did the very same than you did, just slightly names changed. And I will show you in my Windows world how to do it. Let me just add one small thing about the bashrc export. We can also just copy it from the Epics controls website. Then you don't have to remember it. So there's this easy path where you can just copy it. So in the next step, I will show you from my computer how to set it up and how to communicate with our heads and see what you have to do. Okay, now I'm not there with the video output anymore, but with two windows, because I want to explain to you how to install everything what you need for our Raspberries with our website and a terminal emulator. That's what you see now where my video was before. So I'm working here on a Windows machine in contrast to Heinz Mac, and I just decided to go for MOBA Xterm software to use to have SSH connection. You can directly do it in the Windows command line, but I have a lot of sessions going on, so for me it's easier to use that and can do file transfer and stuff like that. My Raspberry is called DemoPi and the user is Epics, so let's just start it. And you can see I'm now connected via SSH onto my Pi. My username is Epics, and if I now look what's installed, you can see it's just an Epics folder. And if we enter the Epics folder, you can see that it's just the Epics base installed into that folder. So we have to do some steps, and therefore we go back to our web page, our epics.mpg web page. And there I have an installation for our MCC duckheads. So we have some information. What is a duckhead? What is the performance of the duckhead? Also a link to the web page. We will need that later on. And you can see we have to byte an IRC. Therefore, we have to byte an IRC example, and so on and so forth. So let's start with building an IRC example. So I go back to my terminal, and I go also back one step. I make a new folder, make dir an AEI folder, for example. Go into the AEI folder, and there I will build my IRC. So let's make base app. Application -t sample, and then we call it MCC. We have to add the -i, and here we are. So you can see that's what Heinz already did with this Raspberry Pi. Just make an IRC app, make a base app. And here it is. I just make this app to see if it's working. You can see it's processing. After some seconds, it will be done. So we have now a fully made base app. You can see it here. Our everything is already built. And now we have to go back to our web page and see what we have to do. As we did already the make base app, we now have to go into our database, and therefore we go into our MCC app. So I have a different name convention there, but you will get it. And there we have our makefile. So let's edit the makefile. I use Nano as the editor. You can use whatever you want. And okay, I think I'm wrong. It's actually in this in the database folder. And here we have to edit our makefile. Therefore, we go into our database. Here you find the makefile, so let's open it up. And we will add a new database for that. So let's just do db. So that's it. So then close it. Save it, and we now will build another file. We call it MCC 118db. And we have to copy everything from here into it. Okay, that's what we have to do in our database. Let's go back to our application. And here we need now some files from our manufacturer from the duck heads, and therefore we have to have these files. And so we just go to the web page again where we have been before. Here are our 4 available models. We have our MCC 180 and MCC 152. We go on one of the heads, and there you find drivers and software, and it's actually a GitHub. So back to our GitHub clone. So we will just clone this this GitHub. It's here. Copy it, and let's go back to our Pi. I will just go back to the very beginning and just git clone it in my home folder. Then we get every file from the GitHub from our manufacturer. There it is. Let's see where it is. There the name is duckheads, so let's go into the duckheads. And here you find a lot of folders, a lot of examples written in C, written in Python. So you can start with that. But for us, it's just important. So let me go back to my web page. We have to have 3 files from this library actually, and they are hidden in 2 folders. So at first we go to the duckheads, and there, to the examples, and there we find the C folder, and in the C folder there's our duckhead utilities.h. We want to copy that into our MCC app. So let's just copy duckheads utilities to home Epics. That's my my account. Then we have the AEI account. In the AEI account, there's the MCC app. In the MCC app, there are our sources where we want to put it into. So that's it. It will be there now. So let's go back into the repository. Now we have our another folder. It's called include. Here are our specific files for the MCC 118 and MCC 152. So let's copy these. Again, to our correct folder. Sources. And the last one, C52. Done. Okay, so let's see if it works. Go back to AEI, MCC apps, sources, and here you can now find our 3 files: the duck utilities, the MCC 180. 190 and the MCC 152, and I forgot the MCC, the duckhead.h. Sorry for that. Let's do it again. We go into our duckheads, and there it is. So let's copy it again. Duckhead to home XAI. MCC source. Back again. So now we have hopefully everything. So I see duckheads.h, duckheadsutilities.h, and our 2 duckheads that we need, that we want to use, the MCC 118 and the MCC 125. So we also, when we go back to our web page, we also now have to build our file, the development file, the MCC 180.h. So let's just build it here. So nano dev MCC 118.c. And I will just really easy copy and paste everything inside. Okay. We additionally have to build a DVD file. So again, nano MCC 118 dev.dvd. Here's our device defined with our analog inputs. So our MCC 118 is an analog input device. So we have it here now. And we now have to add in our make file our three additional commands that we now included here. So let me just nano make file. And we will add from the website these three commands. So let's just add it below here. Copy paste. Okay. And the last thing what we have to do for our first example is to edit our st.command file. So let's go into the IOC boot. There we find our IOC MCC. And here is our st.command. So let's nano st.command and add our new entries here that are our channels on our head. What we didn't tell you in the beginning, you see here that it's called head number 0, and if you choose to add these heads, and you have to you want to go for more than one, you have to decide which head has which number, and it's set by a jumper onto the heads, and I decided to go with head number 0 for the MCC 118 and head number 1. So the next one is then the MCC 152. So let's add it in here. Yes. Save it. Now we have to make it runnable. So chmod, I will ask Heinz because I always forget the command, a plus x or
user u plus x.
U plus x.
Yeah.
And our st command. So now to start our IOC, I will execute the st command. So /st command. Our IOC is started. We have some troubles. We will see later what those troubles are. But now you can see what Epics version we are running. We are running Epics 7. And when we now type in DBL, you can see that we have our new channels here created to our old channels that are actually from the from the example folder, and I will now just duplicate my tab here so that I have a very same tab onto my Raspberry. Here we are. And here we now can use, for example, our CA get, CA put, and CA monitor stuff. And let's go for CA get and our MCC, so the name of my device. So my channel actually is called MCC HA0 and it's channel number 0. And as I didn't connect anything, it's still showing 0. But and you can now check everything, every channel of these, and they are all showing now 0 as I don't have connected anything to it. So that's our first MCC head connected, and it's running. When you go back to the next to our web page, you can find also what you have to do to connect the MCC 152, and that's a digital output, and therefore we have to add some new stuff to our IRC. So let's stop the IRC.
Yeah, but I think we are a little bit late, Patrick. We're running out of time, and I think the software installation of the MCC 152 is according to the 118 and also described. I think it's getting late, and yeah, I thank you very much, and I hope all the attendees are still live and online and have followed the demo, our try to demonstrate how to install the stuff on the Raspberry Pi with analog digital interfaces. And I just want to mention there is also a very good information source. That's the Tesh Talk, the Epics Tesh Talk. And if you have some questions about Epics, you always get help from the people watching the Tesh Talk. And the link to the email address can also be found on epicscontrols.org. And this is a really helpful information source from the Epics community. And I think we should stop here. It's here in Europe. It's past 8 in the evening, and for today I think it's enough. And thank you all the attendees, and I would wish them a good day in the American hemisphere, in the Western Hemisphere, and the others we will see them tomorrow morning at 10. There's the question and answer session to the stuff we presented today. Thank you very much, and goodbye till tomorrow.
Also goodbye from me. See you tomorrow.